Hello friends. Today we will get acquainted with a switch from the new Star Feather series by the well-known Chinese manufacturer MOES. These devices stand out with a number of interesting features. A touch surface that responds to pressing across the entire area of the switch, and not only in specific zones as implemented in most models. Induction mode, allowing you to control the switch without even touching its buttons. Customizable backlight for each key. State memory after power restoration. Scene mode, in which a key is unlinked from direct relay control and can be used to trigger automations. The hero of this review will be the version with the maximum number of keys, 4, with a Zigbee interface. In addition to the standard Tuya Smart control system, we will check its compatibility with all major popular smart home control systems. HomeKit, Google Home, and Home Assistant using the Universal Matter protocol, as well as direct connection to Sonoff iHost, and again to Home Assistant through the ZHA integration and the Zigbee 2 MQTT add-on. And before we start, as tradition goes, I ask you to like this video and leave a comment under it. This will help other people interested in the topic of smart homes to find it. And subscribe to my channel if you haven't done so before. Model, MOES Star Feather, SFL01Z. Input voltage range, from 90 to 250 V. Maximum current, no more than 10 amp total and 10 amp per line. Interface, Zigbee 3.0. Number of keys, from 1 to 4. This review presents the version with 4 keys. Body color, black or white. Form factor, European and American. This review uses the European version. A neutral wire connection is required for operation. Dimensions. External, 86 by 86 millimeters. Internal, 51 by 51 millimeters. Depth, 25.7 millimeters. Base ecosystem, Tuya Smart. The device comes in a branded black box indicating the Star Feather model name and the manufacturer's logo in the upper left corner. On the back side of the package, the model number, brief technical specifications that I have already mentioned, as well as the version, number of keys, body color, and interface type are indicated. In addition to Zigbee, there is also a Wi-Fi version of the device. The package contents are minimal but sufficient for installation. In addition to the switch itself, the box contains an instruction manual in several languages, the most detailed being in English. It is suitable for both the European and American versions of the switches, which differ only in body size. The set also includes 2 mounting screws. As I have already mentioned, I received the black version, classified by the manufacturer as gray, with 4 keys for the review. The front surface is divided into 4 zones according to the number of keys, with pressing working across the entire surface. This is the first difference from most touch switches, where the sensitive area is usually made as a small circle in the center, which you have to hit. On the back panel of the switch, there are 6 screw contacts, incoming phase and neutral, as well as 4 output phases. Here the main technical specifications I mentioned earlier are duplicated. It is logical that for the sensor, induction mode, and vibration feedback to work, a neutral wire is required. However, a little later in the review, I will definitely check whether the switch can work without it. The design is made so that wires are connected from the back side, and the screw heads are located on top. This is convenient during installation, as it is easier to access them with a screwdriver. The front panel is removable. It must be removed for installation into a mounting box, as the fastening elements are located under the panel. To remove the panel, on the upper and lower side edges of the switch there are special slots. You need to insert a thin tool into them to pry and remove the front part. This is what the switch looks like with the front cover removed. In the corners, there are 4 plastic latches holding the panel. In the center there are 2 contact pads, one with 4 contacts, the other with 2. The round element, apparently, is a magnet. The switch can be installed in a round mounting box, but there are nuances. It does not fit freely and can be installed only in a few positions. In the others, the side mounts get in the way. The problem is that in those positions where the switch fits into the round mounting box, its mounting holes do not match the screw holes in the box itself. In other words, you can insert it inside, but how to securely fix it is a big question. With a square mounting box for a switch 86 by 86 millimeters, there are, of course, no problems. Everything is installed as it should be. The holes fully match the mounting screw locations. Everything is without complaints. The advantage of switches with a neutral line is that they can operate without connecting a load. It is enough to supply the incoming phase and neutral. In the case of this model, it can even be used as a 4-key scene switch by enabling the mode that unlinks the keys from the relays. Nevertheless, for testing, I will connect a load to one of the lines, in this case, an incandescent light bulb. This is what the test bench looks like. The switch is supplied with phase and neutral, with this same neutral connected directly to the light bulb. The phase wire of the light bulb is connected to line L1 on the switch. Here you can hear the click of the relay and the sound of the vibration motor feedback. Key backlighting. By default, it lights up on those keys that are in the on state. For keys that are off, there is no backlight. However, this can be changed in the settings. I will talk about this a little later. Pairing mode is activated when power is first applied. You can enable it manually by holding down a key until the backlight starts flashing. We traditionally begin the logical part of the review with the standard Tuya Smart control system. Since this device works via the Zigbee protocol, a gateway is required to connect it. I am using the MOES Zigbee thread version with support for the Universal Matter protocol. I switch to the mode for adding a new device. The switch must be in active pairing mode at this time. After some time, the gateway detects and connects it. Everything went smoothly. The device was recognized as a smart switch. Let's move on to controlling the switch. The main window is divided into two tabs. By default, the switch tab is active, and the second is scene switch. Currently, all 4 buttons control the switch's relays and are located on the switch tab. Pressing any of them triggers the corresponding relay. In the lower left corner are 2 buttons, turn on and turn off, which can be used to turn all relays on or off simultaneously. Next to it is the schedule button, where you can configure the on-off schedule for each line of the switch depending on the day of the week and time. You can set either automatic turning on or turning off. Next is the countdown button, which can be used to control any of the switch's relays. Here you set a time interval after which the relay will switch to the opposite state. If it was on, it will turn off. If it was off, it will turn on. And finally, the Tools button, where the most options are collected. The first one is backlight switch. In theory, it should control the backlight of the switch's buttons, but in practice, I did not notice any difference in the device's operation depending on the position of this toggle. The next option is the state memory setting after power restoration. It is common to all switch relays and can be set to one of 3 modes: always off, always on, remember last state. Next comes the key backlight control button. This function works correctly. There are 3 modes available. Backlight always off. Default mode. The backlight turns on when the relay is active. The most logical option. The backlight turns on when the relay is off. This is convenient, for example, in the evening, to make it easier to find the switch on the wall in the dark. The next toggle is induction. This is an interesting feature. When enabled, the switch does not require touching the sensor to operate. You only need to bring your finger close to it. If the option is disabled, control is possible only by direct contact with the sensor. Below is the vibration feedback setting. 4 modes are available, where 0, off, and 3, maximum feedback strength. The menu ends with the inching mode for each of the 4 relays. Here you set the time in seconds. This is the interval after which the relay will automatically turn off after being switched on. At 0, the mode is disabled. At any other numerical value, it is enabled. It was not possible to determine the maximum duration. I scrolled through the menu to a value above 2,200 seconds, but did not check further. For the test, I set the inching mode to 1 second on the first relay. Here's how it works. The general settings menu of the device contains nothing unusual. Everything is standard. Available here: support in third-party control systems, device information, shared access settings, a list of automations it participates in, adding it to the home screen, and checking the firmware version. The current version was installed by default. From here, you can also remove the device from the system. Now let's check the key operating modes. As already mentioned, by default they work in relay control mode. Under each key in the main screen of the plugin, there is an edit icon. Clicking on it takes us to the key settings menu, where you can set the operating mode, name, and change the icon. When switching a key to scene mode, you can also specify its name, choose the scene it will control, and set an image to be displayed on the screen. After switching a key to scene mode, it disappears from the Switch tab and appears on the Scene Switch tab. Here you can specify which scene will be launched when pressed, or use this key as a trigger for automation. You can change the operating mode for any number of keys, even for all of them at once. This way, you can fully switch the device into a logical mode where each key is used exclusively in automations. And since we've started talking about automations, let's look at the capabilities of our device in this area. Let's start with triggers. Quite a large number of options are available here. In automations, you can use the state of each relay of the switch, on or off. Pressing a button switched to scene mode. Only one action is available here, a single press. The state of the induction switch. In addition, you can use the inching state for each switch. Comparison conditions available. Greater than or equal to. Less than or equal to. Within a given range. Outside a given range in seconds. It is also possible to track the vibration feedback level. This switch can also be used in the automation actions section. There are quite a lot of options here, especially considering that in our test we have the 4-key version. Each relay of the switch can be turned on, turned off, or toggled to the opposite state. For each relay, you can set a timer in seconds, as well as control the induction switch. Control of the inching mode with its duration set in seconds is available. I remind you that a value of 0 disables this mode. In the example shown in the slide, the automation uses a switch button set to scene mode as a trigger to control one of the relays of the same device. Unlike unconditional triggering in standard mode, automation can take additional conditions into account, such as the time of day. During the day, control the switch's relay. At night, turn on the logical backlight or a nightlight. This is how control through automation works in scene mode. Now let's check an important point that will surely interest many viewers, whether this switch will work without a neutral line. The test bench remained unchanged, except for one thing. I disconnected the incoming neutral line from the switch. The neutral to the light bulb continues to be supplied, but now only the phase comes to the switch, which is then connected to the light bulb through the L1 output. Unfortunately, with such a connection, the switch shows no signs of life. The keys do not respond, the backlight does not work, and vibration feedback is absent. The device definitely requires a neutral line. As already mentioned, the gateway to which the switch is now connected supports the Universal Matter protocol, through which it is also integrated with several other smart home control systems. Let's check whether the switch has been passed through the gateway, starting with Apple HomeKit. I go into Settings mode and select Hubs and Bridges. Here I find the corresponding gateway, and in the Accessories menu, I see a new device, a 4-key switch. From here you can control each of the 4 relays of the switch, including via the Siri voice assistant. I remind you that in Apple's Home app, you can display either all 4 switches in one window or split them into 4 separate ones. This is especially convenient if the switch relays control lighting, for example, in different rooms. In Google Home, where the gateway is also connected via Matter, 8 tiles were detected, 1 for each relay and 1 for each scene key. The relays can be distinguished by their displayed status. In the left screenshot, all of them are in the off state. In the center screenshot, I have turned on all 4 relays. If you open the tile of a specific relay, there will be an available on/off toggle. The properties of each of the 8 newly appeared objects look identical and are sequentially numbered from 2 to 9. The third system to which the gateway is connected via Matter is Home Assistant. Just to clarify, everything shown earlier, Tuya Smart, Apple HomeKit, Google Home, and this Home Assistant integration, works simultaneously. Here, in the upper block of the interface, Control for each of the 4 relays of the switch is displayed. The second block in this window contains the logical keys. Events appear here when they are pressed, but there are some nuances I will describe next. Currently, all keys operate in standard relay control mode. As can be seen in the logbook column on the right, the last key press was 43 seconds ago. At the same time, in the second block, the last change in logical keys was 6 hours ago. This means that in relay control mode, scene keys do not generate press events. Now I switch the keys to scene mode. This is done in the Tuya Smart app. In this mode, when you press any key, logical objects in the events section begin to register presses, as seen by the updated change time. Each button here is displayed as a separate object, and its history shows that pressing it registers a specific event. Let's see exactly which events are recorded. According to the attributes of each button's event object, 2 types of events are recorded: initial press and short release. The first appears when the key is pressed, the second when it is released. I wondered whether these could be separated so as to get 2 distinct events from each button. I created a simple automation, setting as a trigger the state change of each object corresponding to the events of a specific button. These objects have identical names and differ only by the number at the end. As an action, I set up a system notification showing from which button and what type of event was received. Essentially, this is a monitoring automation that outputs the event name from the triggered trigger. With every press of any key, the system displayed 2 notifications in sequence, indicating the pressed key name and the event type. Events were recorded consecutively. First initial press, then short release. It's not possible to split these events. They come one after another immediately. Therefore, in this connection mode, there's no particular point in separating them. As a trigger, you can simply use the state change of the desired key. When pressed, the event changes its state, and the automation will trigger. The only thing worth adding is a small delay, for example, 1 second, at the end of the automation. This will prevent retriggering, since pressing a key generates 2 events in a row. And before disconnecting the switch from the gateway, let's also check the standard Tuya integration, which, as a reminder, works via the cloud. Here everything is quite simple. The switch did not appear in the list of supported devices. Through Matter it works, but through the standard integration, at least at the time of testing, it was not displayed. Now let's proceed to disconnect the switch from the standard gateway. By the way, when this is done, it automatically goes into pairing mode. Next, let's check its compatibility with alternative systems. We will start with the Sonoff iHost Smart Home Controller, which, as a reminder, has its own Zigbee coordinator allowing such devices to be connected directly. The firmware version at the time of testing was 2.6.1. When adding a new device, the switch is successfully detected and displayed correctly as a 4-key switch. However, there is a nuance. In Sonoff iHost, all unsupported devices are displayed in exactly the same way as a 4-key switch. In the device card, in the upper right corner, there is an icon showing its role in the Zigbee network. The letter R indicates that it is a router. It can relay data to and from other network nodes, thereby extending its range and capacity. This nuance with unsupported devices is worth noting. At the time of testing, this switch is not supported by Sonoff iHost, even though in this case its icon matches the real device. Therefore, the only option is to remove this switch from Sonoff iHost and move on to testing the next system. Traditionally, right after Sonoff iHost, I check compatibility with the standard Zigbee device integration in Home Assistant, called ZHA. A USB Zigbee stick with SkyConnect firmware is used as the coordinator. I start pairing mode for new devices. The switch, after being removed from Sonoff iHost, automatically enters pairing mode. The device completes the interview process and connects, but even at this stage, it's clear that the system has detected only one entity. Thus, we can confidently say that this switch is also not supported in ZHA. Going to the device page confirms this. Only one standard entity is available, which is present in all devices without exception, the firmware version check. By the way, I have never seen it work correctly. Therefore, at the time of testing, we can conclude that the Star Feather switch is not supported in ZHA. And the last system for today with which we will check the switch's compatibility is the Zigbee 2 MQTT add-on, with the current version at the time of testing being 2.6.0. In this version of Zigbee 2 MQTT, the MOES Star Feather switch also does not have official support. However, this problem can be solved with the help of an external converter. Moreover, I can confidently say that by the time you are watching this video, official support for this switch will most likely already be available. And here's why. I'll show you now. At the moment, the project page already includes support for the 2-key version of the Star Feather switch. When I opened the official converter file for MOES devices to see how the external converter was implemented, I discovered that it already contains support for all versions, including the 4-key version. In this screenshot, you can see the relevant section. 3 model variants are listed, including the one I received for testing. In the list, it comes first, so there was nothing to invent. I simply created an empty file in the Zigbee 2 MQTT/external_converters folder, named it after the model number, added the formatting with links to the used libraries, and inserted the code from the official file into the converter. After that, it only remained to restart the add-on. The code for this converter, if you need it right now, can be found via the link in the video description. After restarting, the device received the status supported. It is currently indicated that support is provided via an external converter, but I think that in the next update, it will already be officially supported. Let's move to the exposes page and see what is available here. The list includes 4 relays of the switch, which can be controlled regardless of the current key mode, relay control or scene mode. Next are 4 countdown settings, 1 for each relay. They can be set directly from here, as well as from the Home Assistant interface or through automations. This setting corresponds to the inching parameter in the stock app. Here you specify the duration in seconds, the time after which an active relay will automatically turn off. At a value of 0, this mode is disabled. Then comes the block for configuring the operating mode of each key. By default, the relay control mode, switch, is active, but you can switch a key to scene mode, in which pressing it does not cause unconditional relay state changes. Next is the action entity, which receives events when a key is pressed in scene mode. Following that is the backlight setting, the purpose of which I could not determine. Regardless of its state, I noticed no changes in the switch's operation. The last one in this block is the power-off state memory setting, which applies to all 4 relays of the switch. Here's what the events that can be used in triggers when operating the switch in scene mode look like. In the action object, if, of course, this option is enabled in Zigbee 2 MQTT, as I showed in the lesson on installing and configuring Zigbee 2 MQTT, events of the form scene_switch_number will be received. Accordingly, scene_1, scene_2, scene_3, and scene_4. So, we have found out that the Star Feather series from MOES has a number of exclusive, one could even say unique, features. Among them, a touch surface that responds to pressing at any point of the front panel, vibration feedback that lets you know whether the press has been registered, convenient backlighting for each key, a key-to-relay unlinking mode, which is often missing in many otherwise interesting switch models. I'll remind you, such a mode is most often found in Acro switches. From the test results, we can say that the device does not yet have broad support in smart home control systems. However, in the popular Zigbee 2 MQTT, it can already be used right now. The specific features of this model include possible difficulties when installing it in a round mounting box. The screw holes may not align, although this issue can be solved in principle. A more significant factor is the need for a neutral line, which is often missing in switch mounting boxes. However, if it is available, the device can even be used without connecting a load, as a logical switch with stationary power that does not require battery replacement. That's all for now. I hope this video was useful and interesting for you. I will be grateful for your likes. They help promote the video on YouTube. If you don't want to miss new reviews and tutorials, subscribe to my channel. As a reminder, in the video description you will find all the necessary links to stores where you can purchase this device, as well as to my social networks, Telegram channels, and groups for communication on smart home topics. Join in, it will be interesting. Thanks for watching, see you next time. Peace to all.